Welcome to the second video for Westminster's computer graphics course. This is going to go over what you need to know for the first project. This project will be very bare bones, and I'll pretty much spell out exactly what you need to do. This project is really just meant to alleviate some of the mystery of what the WebGL API feels like. This will also be a good time to figure out if there's any configuration issues with your computer, so we can get this sorted out now, although I don't really think you'll run into many issues. Additionally, you'll be able to use the code you write here as boilerplate for the future projects. That way you won't feel like you're starting completely from scratch on those. First, I'm going to just give you this HTML and CSS code because I couldn't even be bothered to remember this layout stuff, and it's just the baseline template we'll use for every project. That being said, just so it's not a mystery, I'll briefly explain what's going on here. This whole top section is just the CSS styling for the web page. The body rule isn't specific to computer graphics, and it's just telling the browser that everything on this page should stretch to be completely full screen without any borders or scrolling. The canvas element, however, is where the graphics will live. HTML was originally built for boring things like text documents, not hardware-accelerated rendering, so the canvas element was introduced in HTML5 to let us draw a custom geometry. The canvas element creates a blank pixel grid on the screen. It doesn't follow normal document layout rules and hands complete control over the JavaScript, which is how we pass our graphics data directly to the GPU. An analogy I find useful is thinking of the body as the gallery room and the canvas as a giant whiteboard mounted to the wall. You can actually draw on a canvas using plain JavaScript, but you'd be asking the CPU to handle calculations pixel by pixel. This is incredibly slow because CPUs are built to handle complex tasks one at a time, whereas GPUs are built to handle millions of simple tasks simultaneously, like figuring out the colors for millions of pixels. This is where WebGL comes in. WebGL is a set of tools that gives us a direct pipeline to the GPU, allowing us to render sophisticated scenes incredibly fast. Right here is where we're actually creating the canvas element in HTML. Now that I've covered that, I'll get into what you're actually going to write. Everything inside these script tags will be written in JavaScript. If any of this web development stuff is new to you, I want you to know that I didn't know any of this until I started making this curriculum, so don't worry about it. The first project is likely the most you'll have to think about web development in this entire course. The first thing you'll do here is create a function in JavaScript that will contain the logic to render a red screen. And then right below that function, you're going to set window.onload equal to the name of your function. This part also isn't specific to WebGL. It's just telling the browser that once the HTML document completely finishes loading, run this function. Inside your function, you're going to grab a reference to the canvas element that we created up here so that your JavaScript can talk to it. You'll use document.getElement by ID to do this, which also isn't specific to WebGL. Next, you're going to want to set the resolution of your canvas. To do this, you'll just set the canvas width and height here to the window width and height. I know I'm not explicitly showing you how to do this, but that's just because I want you to go look at some documentation and play around with the code a little bit. Now, for this project specifically, it won't make much of a difference if you set the resolution or not. This is because the screen is just going to be red either way, so it doesn't really matter what that resolution is. But it'll be nice to just have it here now for the rest of the projects. Now we're finally getting to something specific to WebGL. You're going to call a function here called getContext on the canvas element, and you're going to pass the argument WebGL as a string. GetContext tells the canvas element exactly which graphics engine we're going to use to paint the canvas with. By passing WebGL, we're explicitly initializing WebGL. GetContext will return an object containing all of WebGL's functions and constants, so you'll want to assign that output to a variable. Most people just call it GL. So now whenever you want to call a function specific to WebGL, you'll call GL dot, then the name of the function. Now we have access to hardware-accelerated drawing tools. This object contains every function, tool, and setting we need to communicate with your graphics card. Before talking about the code you need to change the screen's color, I'm going to talk about how computers interpret color in general. Computer monitors use the RGB or RGBA color space. A color space is just how we define colors in general. Your screen can display millions of different colors per pixel, but the hardware needs numbers to understand what to actually display. This is what a color space achieves. RGB stands for red, green, blue. So for the RGB color space, there's 3 values, each ranging from 0 to 255. They can be normalized to span from 0 to 1, where 0 means the color channel is completely off, and 1 means it's completely on. In this normalized system, a 0.5 corresponds to the integer value 127 in the unnormalized system. If we have 0, 0, 0, that's black, and 255, 255, 255 is white. If we have 255, 0, 0, then we're setting the red channel to its maximum capacity, and the rest are empty, resulting in solid red. 0, 255, 0 is entirely green, and 0, 0, 255 is entirely blue. If we mix red with blue, we'd have 255, 0, 255, or in a normalized system, it would be 1, 0, 1, which would give us purple. RGB is not the only color space out there. For example, digital artists often prefer the HSB color space, which stands for hue, saturation, and brightness. Artists prefer this because it's much more intuitive to how we think about color. That being said, no matter what color space you use in software, when these colors are actually pushed to the physical screens, they are ultimately transformed back into RGB because that is how physical display subpixels are laid out. I mentioned the RGBA color space. The A stands for alpha, which represents opacity. We don't need to worry about opacity for this project, so we'll just leave it at full opacity for now. Now, to set the canvas to red and wrap this up, we're going to do 2 things. First, we'll configure the color the screen defaults to when it resets, or in other words, is wiped clean. Then we'll tell the GPU to actually perform this screen clear operation. You will use gl.clearColor to set that default reset color. This is an important time to tell you that WebGL is considered a state machine. Think of WebGL as a giant physical dashboard full of switches and knobs. Once you turn a knob to a specific setting, WebGL holds that exact value in memory until you walk up and turn it again. The clear color is an example of one of those knobs. By running the clear color command, you're turning WebGL's internal color knob to red in this project. Note that nothing actually changes on your screen when you do this. You've just adjusted the setting on the imaginary dashboard, but you haven't actually cleared the screen yet. This is what gl.clear will do. The interesting thing here is that gl.clear requires an argument. You can't leave the parentheses empty. This is because WebGL manages multiple different buffers, or what you can think of as digital images or canvases, even if you aren't seeing them. I'm going to be throwing around the word buffer in this class a lot, so I should be clear that a buffer in computer graphics is just a dedicated block of memory on your graphics card meant to hold a set of data, in this case, an image. WebGL needs to know explicitly which buffer you'd like to wipe clean. For our project, we're wiping the buffer responsible for storing pixel colors. Don't worry if this next part doesn't completely click yet, we'll explore it much deeper in other projects. But there are other buffers available too, like the depth buffer. The depth buffer is a completely separate layer on the GPU memory, and it tracks how close objects are to the camera. The reason we use a bit mask in this function is so that we can clear multiple buffers at once with a bitwise OR operator, like this. By combining them with that vertical pipe character, this instruction will clear both the color canvas buffer and the 3D depth buffer at the same time. In our case for this project, we only care to clear the color buffer. So to reiterate, gl.clearColor turns the knob to set the color we clear the screen with, and gl.clear with the color buffer bit passed in is what will actually clear the screen with that color. And lastly, I thought I should mention that this whole program, once it's completed, is about 45 lines of code, whereas an equivalent program in Vulkan API would typically be about 800 to 1200 lines of code, which you would then need to figure out how to compile in C++.